Hey, so I'm going to show how to create a procedural font in Houdini. And here on the left, you can see the characters, and here in TextEdit, you can see me using the font. And this is using an SVG exporter code, which I mainly got from this Intagma video called Importing and Exporting Vectors to and from Houdini. I've also made some minor updates, and I'm going to cover that here. The other thing this is using is a program called BirdFont. I've also I tried using FontForge before, but it was just a little difficult. BirdFont seems more modern. It's also free and cross-platform, and it's just a little easier overall. So I'll get into the workflow there. But yeah, to start off with, I'm just going to show this export SVG node by itself, just how it's used, and then I'm going to get into the font creator code right here. And I should mention this specific font effect is basically just taking Comic Sans and then applying some poly reduce on it, and that's pretty much it. So I think there's a lot of possibilities for using Houdini's procedural tools to create text effects and fonts. So hopefully this is useful. Yeah, so I'm going to put the link to this HIP in the description of the video. I'll also put the export SVG node as a standalone HDA up there too. Yeah, so let's look into this export SVG, what we got here. So there's two inputs. First one is polygons. Second one is bounds. So I should mention, in the Intagma's video, the bounds were being calculated dynamically based on the size of the geometry. And that wasn't really working for me because I want to have a fixed height for my font. And so I changed this a little bit to accept an explicit bounds object. Yeah, so here's the circle. Let's just isolate that. Here's a circle geometry, and it's a polygon, just a regular circle sop. And then what do I have here? I have a primitive wrangle. This is just setting some attributes, primitive attributes, which can be used by the SVG exporter. These are optional, so I'm just going to turn them off temporarily. And then it's just a regular, bound node, bound sop. Both those are going to the SVG. SVG has an auto run parameter, so every time it recooks, it'll write this file out. Here's the path, and then there's an output scale. So this will just basically convert the Houdini coordinates into SVG coordinates and basically just multiply the width and height by the scale value. Stroke width, determines how thick the lines are in the SVG. So this is based on p scale, which is on the primitive attribute p scale. And so if p scale is missing, it's going to default to 0, which will always end up using this lower bounds value right here. So essentially what will happen is p scale will be remapped from its original min and max to this new min and max range. But if p scale is absent, it'll just always use this lower value here. So I can just show this in action. It should just auto run. And if I open my Finder here, let's see if I can find where this is. Yeah, so circle SVG right here. Yeah, let's see. It should rewrite this now. Yep, there we go. So it's just outputting the lines of the circle. And you can see I want to customize the stroke width. Let's just bring it down to 5. This just updates right away. You can also set the stroke color right here to red, for example, and then also set the fill color. Oh, what have I done? Oops. Yeah, and these things also do accept, I know, like hex strings. So like 0, I think. I don't know. So this should cause it to be, yeah, that's another green one. So Yeah, so that's basically how the export of SVG works, kind of on a surface level, sort of treating it as a black box. I will get into the internals of this. The gist of it comes, it's mainly this big Python script right here. I'm not going to explain that right now because I think it's more interesting to dive into the font creation side of things, and then I'll probably cover these internals at the end. So let's just look at what we have going on in this big for each loop on the left. So just starting from the top here, this node right here is a point wrangle, and it's just creating a point for each character that I want to export. So I have a string right here with a bunch of characters separated by strings, or separated by spaces, sorry. And for each of those, it's creating a point at position 0, and it's setting a point attribute called char, or character, to that string value. So you see here, there's 1 point for exclamation mark, 1 point for Q, etc. for everything else. Then we're going to go through a for each point loop. And eventually, each character is going to be written to its own SVG file. And the program BirdFont can auto load the characters and assign them in these correct slots based on the naming convention. So for example, if I have like a.svg, it'll automatically load it here. But for some of these other ones, like exclamation mark or comma or period, I don't want to do like period.svg because that doesn't really make sense as a file name. So instead we can use this Unicode point name. So this would be like u plus 2e.svg. That's what we're going to save it out as. So that's what this customized file name is doing. By default, the file name will be the same as the character name. And I'm writing this to the string attribute char name, or yeah. And so in the case of Z, it's the same. But as you see in this wrangle here, for a lot of the other characters, I'm just setting the Unicode value. And yeah, I was having some issues with, I think like the capitals and the lower cases were overwriting each other. So I ended up just giving the Unicodes for the capitals as well. I'm not sure if this is really necessary. I might be able to remove this, but anyway, it doesn't hurt. So yeah, at this point, we still have 1 point with a character attribute and a character name attribute. And now, like I mentioned, the effect itself is doing a polyreduce, and basically I'm polyreducing here down to 3%. And this works for a lot of the characters, but some of them were unreadable. So I needed to polyreduce a little bit less intensely. So I have another point wrangle right here, which just kind of, applies a different poly reduction depending on, for certain characters. So we end up with this another attribute called reduce here. It's usually 3, but for some of them it's like 4, 5, or 6, just depending on what looked good in the output. Yeah, and so I'm just having a null right here, which is just representing that point with its attributes, and I'm going to reference it down here. And the next thing, we have a font, and this is going to use the points function to read that string value from the input node right here, and just create a, let me just highlight this one. And I'll explain why it has the letter A in front of it in a second, but I just want to mention that the point function in Houdini, like point, is a normal thing you use in Vex. And this, as you see, it returns a float. We want to return a string, so we have to actually use points. That tripped me up a little bit. Now, why do I use an A? Let me just demonstrate this. So I'm going to create a standalone font node here. And I'm just going to set this to comma, just only having comma. And actually, we can just, let's just say, and now I'm going to do like a comma. If you notice that comma is now vertically offset, and it kind of looks more correct here, right? Whereas by itself, it's vertically centered. So since I'm creating a font, I want the characters to have the correct vertical offset. So I am adding this fake A character at the beginning, this extra A. And I'm checking add text attributes on the font here. And on the primitive, you can see there's text index 0 to 1. And then I've just put a blast, and that blast just removes the A. So vertical positioning is correct. However, it is it is offset with the horizontal positioning. So I just need to use a match size here with justify X, center to min, and that is looking like it's bringing it there to the center. So that looks good now. And now, yeah, we do our polyreduce effect. So there's a remesh here, and then a polyreduce. And then I'm using ends with close U, unroll to shared points. That's getting this kind of wireframe effect. And then this transform here, I'll talk about this in a second, but from the polyreduce, we have a bound, which is just getting that bounding box. And then that is actually offset a little bit. So this bounds X. Then we have a grid, and this is sort of creating the framing for the character. So the size of the grid is the bounding box of the character, plus some padding with the horizontal, and then the Y size is fixed, and that's all on this export params node right here. And this this quote unquote extra width ends up being the kerning. So that's what this transform is for also. So it's just because when I have everything all laid out like this, I need to, if I turn off this transform, you can see the effect it's having. So right now this dollar sign is a little bit out of bounds. So I just need to bring that up a little bit. Bring everything up a little bit so everything's fitting correctly. Yeah, what else? So that's that transform. And then I'm just pretty much passing this into export SVG, with my bounds object. And the output scale is 103. I kind of got this with trial and error, with this program BirdFont. I'm not really sure how to kind of get this in a more scientific way. And you notice here that the font, they don't even look correct here, but they actually work correctly when you install them. So this value of 103 just seemed to work correctly to get it the right size. Yeah, and I'm using a stroke width of 3, and then this is just for visualization at the end here. So that's kind of the meat of the matter there. This transform is just sort of doing a little bit of a grid layout stuff. This is just for visualization. So lay it all out so I can double check that it's all good. All right, so now I'm going to show the actual font creation part of it. So in my chars folder here, I have all my characters. And so I'm going to go into BirdFont and create a new one. And then go open this menu, click Import, Export, Import SVG folder. And then I'm going to select a folder. And then I'm going to press set width of the glyph to that of the SVG file. It's hard for me to say exactly what this is doing, but it seems to make it so that the fonts are centered. So I'm going to go ahead and do that. It's going to take a minute, and there we go. 85 files have been imported. So I go back to the overview. A little slow, but give it a sec. And here's all my characters. At this point, I want to save the font out. So I do Command S, and I'm going to just save this as tutorial. And this is not saving a font. This is saving the BirdFont, file. And then you want to go up here and do import and export again, and then export fonts. And then just click export, and you can change the file names if you want. But I'm just leaving everything the same here. It's exported to TTF, which is true type font. And that's kind of the more typical one that you'll see distributed around. I really like font space, and all those. Most of those are TTFs. Yeah. So I'm not really super. I'm not good at fonts or anything. So, but I should mention, yeah. So this the kind of parameters you want to control. One of the important ones is this extra width. So if I turn this down to 0, you can see that the horizontal bounds of these rectangles are just perfectly touching the ends of the objects, and that's basically going to make the font look unnatural because there's no space between the characters. So you want a little bit of extra width here, and this is basically the kerning. It is possible to vary this between characters using the same approach I've shown up here, and then you just read it from an attribute. But for now, I'm fine just to have it all a uniform size. So I guess it's time to look at our font, which has been created. So I right-click on this, open with Font Book. Yep. And then here it is. Looks great. So just going to press Install. And then here's tutorial font. So if I want to test this out in text edit, let me just type in some text. Well, so I'm already basically doing it, but you want to do show fonts here. And then what was this one called? Tutorial. So, yep, that's it, tutorial. And then, you know, we have all our special characters and totally unique and interesting font, I think. So yeah, I mean, you can see that, you know, it's not perfect. Like, yeah, I had some issue there with seemed like the J and the Y. Yeah, so there's a little bit of overlap. I might need a little more. If you see this $sign and the 8 are like right next to each other, so I might need a little bit more bigger fixed height. So that'll just kind of grow those. But you can screw with this a little bit and bring it into your text editor and play with it a little bit. Yeah, I think I'm going to call it there. Oh yeah, I was going to talk about this export SVG, the internals here. So this stuff up here is just basically setting, you know, initializing the Pisco attribute if it doesn't exist, setting it to 0, and then these are attribute promotes, which are basically getting the maximum and the minimum Pisco value. This is a common trick. You can, if you want to see like the maximum value of an attribute, you promote it to detail, and then you do the promotion method maximum or minimum. And then here you can see on the geometry spreadsheet, you have the max P-scale and the min P-scale. And then this attribute wrangle is basically just performing the remap within that range we've specified. And then this Python SVG export node is sort of the kind of the meat of the matter, I would say. So let's kind of get in here. So what triggers it is down here, if node eval parm auto run, then call the run function up here. Oops, what have I done? Oh no, I think I killed it. Oops. I don't know, I accidentally pasted something. We definitely not save that. I think I can, yeah, there we go. Okay. So the run function, it has a handle on the node, which is the polygons. That's the first input here. And the second input is the bounds geometry. And so we fetch the actual geometry from the, let me just, yeah, we fetch the actual geometry from the polygons, and then we fetch the actual geometry from the bounds object, and then we calculate the bounding box from the bounds object. Read some of our parameters, yeah, we basically get the minimum x, minimum y. That's from the bounds object. We calculate the width and height based on that. So, for example, the max x minus the min x will give you the width. And then it's kind of just some boilerplate to generate a SVG file, which I kind of got this from the Entagma video, this stuff right here. But we're looping over the primitives, and we are reading some attributes from the primitive. And this is custom stuff, so reading the stroke width parameter and the stroke color and the fill color, and checking if the polygon is closed by reading the prim intrinsic. So Houdini's automatically calculating for every primitive if it's open or closed. So you just have to use the intrinsics to read that, and that's something that's a little bit hidden. You have to go into this intrinsics menu and click close. You can see it's either 1 or 0 there. Yeah, and then that closed attribute will let us know if it's closed. We just have to append this Z character to the end of the path, which tells SVG that it's a closed path. Yeah, and what next? So we have our prim attributes read, and then we read the points from the prims, and we basically call this transform points function, which basically just remaps the points positions within the area that we've specified. So we can take a look at that here. So it'll take the for example, for x, it'll take the point from the old range of min x to max x to the new range of 0 to width. So that's just positioning it in the SVG file correctly. And then eventually we just call right path here. And this is where we're using those primitive attributes just in this path line here. So it's not a crazy complicated piece of code, but you know, yeah, that's pretty much it. I think that'll do it. I'll try and leave the video kind of concise for now. Yeah, that'll do it. All right, thanks for your help. Well, thanks for watching. All right, bye.